Welcome. I wanted to go over this quiz on bonding with you to help you prepare for our quiz on bonding. Let's dive right in. It says, given the balanced equation representing a reaction, what occurs during this reaction? Well, notice first that we have a breaking of a bond. How do I know? Well, obviously, if you have a compound, those two oxygens are bonded together. When we break the bond, we have an O and an O. Now, recall, BARF is a great mnemonic device to help you recall that when you break a bond, energy is absorbed. So the answer is choice 3. 2, which symbol represents a particle that has the same total number of electrons as the sulfur ion? Well, remember, when you look up the sulfur atom, it's 2, 8, and 6. Well, when that becomes an ion, like all good non-metal atoms, it gains one or more electrons to move to 18th street, to become 288. What element is always 288? Well, that's argon. Which of elements has an atom with the most stable outer electron configuration? Well, stable outer electron configuration means noble gases, means group 18, therefore that has to be choice 3. Number 4, which element forms an ionic compound when it reacts with lithium? Well, first of all, what does it mean to be ionic? It means you have a metal plus a non-metal. They've given you lithium, which is the metal, so that means they're asking you which of the following is a non-metal. Bromine is a non-metal. Careful, Kr is also to the right of the staircase. Remember, that's group 18, an unreactive element, therefore we do not consider it either a metal or a non-metal. Number 5, a solid sample of a compound and a liquid sample of the same compound are tested, or each tested for electrical conductivity. Which test conclusion indicates that the compound is ionic? Well, you first have to recall, well, what does it mean to be ionic in terms of conductivity? Well, we said the following. It's a yes and no answer to the question of, is the sample conductive? The answer is yes, when the ionic sample is in the form of a liquid or whether it's aqueous, meaning dissolved in water. The answer is no if it's a solid. Now, they're not asking this, but I want to add, why is this? Well, this means that you have mobile ions present. If the ions can move around, they can conduct electricity. If you have non-mobile ions, well, that means you cannot conduct electricity. Of course, the question's more straightforward. It says the solid is a poor conductor, which we said over here, and the liquid is a good conductor, which is right over here. That is if you are ionic. Number 6. A solid substance is an excellent conductor of electricity. The chemical bonds in this substance are most likely. Well, the only time we've talked about, in general, solids that are excellent conductors is when we discuss metals. In other words, things with metallic bonding. So not ionic. Ionic is not conductive as a solid. Now, the question is why? Is it because the valence electrons are mobile or because they're stationary? Well, I said a moment ago in question 5, it's because the valence electrons are mobile. They can move around. They can conduct electricity. Number 7, a molecular compound is formed when a chemical reaction occurs between atoms of, well, you have to remember that molecular means covalent bonding. Oh, well, as we well remember, covalent means all nonmetals. So in other words, it's asking, give the choice that contains two nonmetals. Choice 3, hydrogen and oxygen, a nonmetal and another nonmetal. Question 8. A chemist performs the same test on two homogeneous white crystalline solids A and B. The results are shown in the table below. Based upon this, you're asked what the results suggest. Well, notice notice if you have a high melting point, you're either going to be a metal or you're going to be something ionic, without looking at anything else. If you have a low melting point, we're going to guess that you're a non-metal. Again, we're generalizing. Now, it's also saying electrical conductivity in aqueous solution. You're a good conductor in aqueous solution. Well, that underscores ionic. Solubility in water, likewise, you can dissolve to a large degree. This is saying you're a non-conductor. So we know that since we're dealing with low temperature and a non-conductor, this has to be covalent. So solid B contains covalent bonds. Now, although this could be a metal, whenever we talk about dissolving, we talk about ionic substances. Metals can't dissolve in water. So that means that solid A contains ionic bonds. No, that's not a yes. And B contains only covalent bonds. Again, high melting point dissolves in water, low melting point, and is a non-conductor. What is the chemical formula for titanium 2 oxide? Let's take this step by step. Ti and O. Titanium, the Roman numeral 2 says that this is a positive 2 charge, and this is, I look up, as a negative 2 charge. We swap, drop, and reduce. That 2 comes here, and that 2 comes here. So recall, when I swap and drop, I have Ti2O2, but I have to remember to reduce that to the lowest whole number ratio. That's TiO. Number 10, little change here. On this quiz, we're not going to have anything like sulfates. We haven't talked about those yet. Let's make this sulfide. Let me advance this a little bit. Next. Due to the fact that I changed to sulfide, I had to get rid of all my choices. This just becomes a part 2 style question. Well, I have Na, which I look up. Na is always positive 1 charge. Sulfide is negative 2. Swap, drop, and reduce. The 2 comes here. The 1 goes there. So my final answer is Na2S. Number 11. Which of the following substances has a high melting point temperature? Now, a lot of you, and this is not being critical, it's an observation I've made over the years, when you see melting point temperature, your first instinct is to go to table S and look up the melting point of the substance. Well, that could help you for elements, fluorine and iodine. But if you notice, these two are compounds, so we cannot use table S to look up their melting points. We have to go back to a generalization. And the generalization was this, that if you are what we call a covalent, if you're molecular, if you have covalent bonds and you are a molecule, these have low melting points. If, however, you are ionic, well then, ionic in general has very, very high melting points. So it really becomes a question of figuring out which one of these is ionic. Well, all nonmetals, covalent, molecule. All nonmetals, covalent, that's a molecule. Nonmetals, covalent. Metal, nonmetal, ionic, high melting point. Number 12, identify the type of bonding in solid potassium. Well, guys, potassium is K. If you think it's P, you're going to get the wrong answer. P is a nonmetal, and P would have covalent bonding. It's not that. K is a metal, so it's metallic bonding. Notice how sneaky they are. This is a Regents question, and they want you to trip you up. They want you to think P when in reality it's K. Don't let them fool you, or me for that matter. Number 13, explain in terms of valence electrons why the bonding in magnesium oxide, MgO, is similar to the bonding of barium chloride. Well, what do they both have in common? It's a metal plus a nonmetal. That means ionic bonding. But if you just say ionic bonding, I can't give you credit because you said nothing about what happens to valence electrons. as we've been emphasizing right along, if you're ionic, it means that valence electrons are transferred from the metal to the nonmetal. Of course, the metal's the big loser, loves to lose electrons. Number 14. Well, this one's a little spicy. Let's take a look at it. Identify the element in period 3 of the periodic table that reacts with oxygen to form an ionic compound represented by the formula X2O. Well, if you are forming an ionic compound with the nonmetal oxygen, well, I need a metal. Well, what metals are in period 3? There are just 3 of them, Na, Mg, or Al. So if I guess, I have a 33 to 30% chance of being right. Why don't we increase our odds a little bit? Let's look at their charges. Na is positive 1, Mg is positive 2, and Al is positive 3. If I have X2O, what would the charge have to be on element X to make a neutral compound? Well, algebra. 2X. I don't know what the charge is on X. I know I have 1 oxygen, and each one has a negative 2 charge. Of course, it has to add up to 0. 2X, therefore, minus 2 equals 0. 2X equals 2. X equals positive 1. So that means the only element that could fill in for X is sodium, because only sodium can have a positive 1 charge. Number 15. Write the formula for copper 2 phosphide. Well, our first order of business is to write Cu, and phosphide is P. Roman numeral 2 means this has a charge of 2. Phosphide has a charge of negative 3. Remember, it's positive, negative. I have to choose the first negative charge that I see for phosphorus, because it's my second. Swap, drop, and reduce. The 3 comes here, the 2 comes here. Our final answer is Cu3P2. Number 16, let's leave this one out. Again, notice it has an NO3. We haven't talked about these kind of compounds just yet, so we'll leave this one out. What I do want to remind you guys is on the quiz, we're also going to have questions about nonpolar and polar covalent, and also which is the most polar, which is the most ionic. So, for example, if I were to ask you, which of these compounds, we'll say CO, N2, and we'll have, let's say, Ki. If we did a little chart here and I ask you, what's the bonding type of this? Well, let's start off with this, the simple. I have nonmetal, nonmetal, so that means this is covalent. Nonmetal, nonmetal, covalent. And metal, nonmetal, ionic. We also learned that we can have a polar covalent or a nonpolar covalent. You are polar covalent if you have 2 different nonmetals. Remember, nonmetals. You are nonpolar covalent if you have the same nonmetals. So, this one is covalent, 2 different nonmetals, so therefore it's polar covalent. This has 2 of the same nonmetal, N and N, that's nonpolar covalent. Oh, but wait, Mr. Segelke, this also has 2 different elements. Why isn't that polar covalent? Well, sports fans, be careful. This is a metal and a nonmetal. That's always ionic. If you remember our little scale, first of all, we have nonpolar at this extreme. Remember, we had the electronegativity difference. It's a difference of 0. If you remember, the biggest difference we can have is 3.3. Now, I said there's a rough division between ionic and covalent at 1.7, which means from 0 to about here, you're getting more polar. But you get to a point that when you cross this line thereabouts, very roughly speaking, you cross over into the ionic range. I guess you could think of it this way. This one is so polar, you can think of it that way, 2 different elements, that it actually becomes ionic. That's a way to think about it. There is a relationship. It is a continuum. Well, okay, I hope that helps. Hey, study. See you at the Quizzy booth.